Okay, last video for chapter 1. Let's focus now on temperature conversions. There are 3 temperature scales you need to feel comfortable with: degrees Celsius, degrees Fahrenheit, and Kelvin. All right, and you need to know how to convert between one and the other. And this you've had in Intro Chem. This is easy stuff, so don't get these types of problems wrong, please. But you do have to know the formula that you need to use in order to convert one to the other. If you are given degrees Celsius and you want to convert to degrees Fahrenheit, what do? You take your degrees Celsius, you multiply it by 1.8, and then you press equals, and then you add 32, and that will give you your degrees Fahrenheit. If you are given degrees Fahrenheit and you want to find degrees Celsius, what do? You take your degrees Fahrenheit, you subtract 32, press equals, and then divide by 1.8. Okay? Now, Kelvin, in order to get Kelvin, you need degrees Celsius. So if you're given Fahrenheit and they want you to go to Kelvin, you have to first convert your Fahrenheit to Celsius and then add 273 to the Celsius, and that will give you the Kelvin. Okay? And then if you're given Kelvin and they want degrees Celsius, all you have to do is subtract 273 from the Kelvin, and you can get your degrees Celsius. The actual number is 273.15. So if you have that many sig figs, you can use 273.15. Most of the time, we just round it and use 273. Okay? So there's plenty of practice in the homework for these types of problems. I'll do one for you guys, but you can just practice using your homework. Just, you got to memorize the formulas in order to figure out the conversion here. All right, so this problem says in winter, the average low temperature of interior Alaska is minus 30 degrees Fahrenheit. So minus 30 degrees Fahrenheit. And I want this 0 to be significant. I want this to be 2 sig figs, because normally a 0 to the left of the decimal we already know is not significant, but I am telling you that the tool that I used is saying this is significant. So this is exactly 2 sig figs. So I want this converted to degrees Celsius and also to Kelvin. So I need to use which formula? Degrees Celsius is equal to degrees Fahrenheit minus 32, right? And then divide by 1.8, and that will give you your degrees Celsius. So let's plug it in. Minus 30 minus 32. I'm going to plug that into my calculator, press equals, and then I'm going to divide it by 1.8. So let me go ahead and do that. Minus 30 minus 32. That's obviously minus 62, and then I'm going to divide by 1.8, and I will get minus 34.444442 sig figs. So my final answer is minus 34 degrees Celsius. Okay, everybody can see that, hopefully. Okay, great. So I did have the problem. Now I want Kelvin. What do? All you have to do is add 273 to this, and you will get your Kelvin. So minus 34 plus 273. Now for addition, we go with the least number of decimal places. Both of these don't have decimal places, so we just add it up, and you get 239 Kelvin. Notice with Kelvin, you don't put a degree sign there. It's just a big capital K. Remember, lowercase k for kilo, uppercase K for Kelvin. All right? Good. So that's temperature, and I think all you have to do is just practice that and you'll be fine. I think I've covered most of the things I wanted to cover in chapter 1. I guess, yeah, that's good enough. Let me see if there's anything else here. I guess I could do this too. No, I think it's fine. All right. Before you jump into chapter 2, periodic table, Okay, I've attached this to Canvas, printed out, and you are going to be expected to know elements on the periodic table. You don't have to know every single element, all 118, but you definitely need to know for sure the first 36. So basically hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, and krypton. Know those super well. And when I say know them, I mean know the symbol, okay, and know the name. You obviously don't need to know the atomic number or atomic mass. You will always be given a periodic table for every single exam. It will be this one, the same one that is on Canvas. Now, what else do you need to know? Out of period 5, you need to know rubidium and strontium, so numbers 37 and 38. You should know zirconium, which is 40. Molybdenum is 42. I mean, honestly, you should know them all, but you know, you don't. These are ones that I tend to use a lot. Silver for sure, 47. Cadmium, 48. Indium, 49. Tin, 50. Antimony, 51. Okay. Tellurium, 52. Iodine, 53. And xenon, 54. So that's out of period 5. In period 6, remember period 6, we'll get into the lanthanide series also. So out of period 6, you should know cesium is 55, barium 56, lanthanum 57, and then tungsten 74, osmium 76, platinum 78, gold 79, mercury 80, lead 82, bismuth 83, and let's go with radon 86. So that is 6th period. And then 7th period, francium 87, radium 88, actinium 89, maybe uranium 92, and all the new ones, those are kind of cool. Oganesson is 118, livermorium, floridium, you could know those, but I think Oganesson is kind of cool. How do you end up knowing them? Make some index cards. Name on one side, symbol on the other, walk around with them at all times, just so that you feel really comfortable with them. You should also do the same with the metric prefixes. Put those on index cards, put the elements on index cards, just carry them around with you, just practicing them all the time until you become really comfortable with them, because you need to know these elements before we jump into chapter 2. In chapter 2, we're going to start talking about naming compounds, and we're going to be doing balancing equations and writing correct formulas. And if you don't know how to write a correct formula, you won't survive chemistry. And you can't write a correct formula unless you actually know the elements. So this is basically like the alphabet. You got to know the elements in order to move on into the higher chapters. Okay. All right, we are done with chapter 1. There's plenty more practice with for all of these problems that I've been giving you. So hopefully you've watched the videos, taken notes, and then just make sure you contact me if you need any help with any type of problem. All right, I will see you on the next video with chapter 2.